Let us now recall the laws of exponents. So let's just run through it quickly. So what is this saying? So if you have two numbers with the same base, so what will you do with the exponents? You simply add the exponents. And if you are dividing two numbers with the same base, so what do you do with the exponents? You subtract the exponents. So remember that it's the exponent of the numerator minus the exponent of the denominator. If you have a number and then you raise it to an exponent and then you raise that whole thing again by another exponent, you simply multiply the exponents. This one is saying that you can you can distribute the exponent. Let me just get my pen. So if you have multiplication inside your parenthesis, you can distribute your exponents. Okay, you can also do that if you have division inside your parenthesis. So you can also distribute your exponents. So remember that you can only distribute the exponents if the operations inside your parentheses are multiplication and division only. One more thing, what is this saying? So if you have a number raised to a negative exponent, so what you do is you just put the base in the denominator and then change the exponent into its positive counterpart and then a 1 in the numerator. Now take note that this thing over here, this x to the negative a, this is also the same as 1, oops, 1 over x raised to a. So what is that saying? You can also just take the reciprocal of your base and then you raise it to the exponent without the negative sign. Now what is the use of this thing that I have just shown you? It is actually useful if your base is a fraction. So for example, if you have 2/3 raised to negative 2. So what you do is you just get the reciprocal of your base and then you can now turn negative 2 into its positive counterpart. So therefore the answer is 9 over 4. That's easier, right? If you compare it with doing 2/3 raised to negative 2, so the 1 over, oops, 1, my 1 got disappeared. Okay. 1 over 2/3 raised to 2, right? If you simplify that, 1 over 4 over 9, and then division of fractions, so this becomes 9 over 4. So it's a bit longer, right? So I always use this if my base is a fraction, okay? And also, a number raised to 0 is equal to 1. Let's look at this example. We want to find the value of 4 raised to negative 1 and so on and so forth. Anyway, let's now compute. Okay. Um, So what will we do here? So we just change all of the negative exponents. We do not want negative exponents. So by definition, 4 to the negative 1 is 1/4. 2 to the negative 3 is 1 over 2 cubed all over 5 raised to 0 is 1 minus 4 to the negative 2 is 1 over 4 squared. Okay. Equals, so this is 1 fourth, 2 cubed is 8 all over 1 minus 1 over 16. So I'm assuming that you're already very good with your operations with fractions. So LCD is 8. This becomes, oops, hang on, 2 plus 1 all over my LCD is 16, 16 minus 1. So we have 3 eighths all over 15 over 16. So we have 3 eighths times the reciprocal. Oops, sorry. Okay, so remember, division of fractions, you turn division into multiplication and you get the reciprocal of your denominator. So I have, this is 5, this is 1, and 2. So the answer is 2/5. Alright, next example, we want to simplify this. By the way, I'm no longer going back to the previous slide, ha. I'm just giving you the answer, but not the corresponding letter. Okay. Anyway, so because of course in this case we really have to solve this. So for our solution, so let's attack. So what is this? What's the first thing that we can do? We have x to the n plus 2 times x to the n. So this 2 over here. So that's, what do you do with the exponents? When you have, we are multiplying the two numbers. So you're multiplying the two numbers, x to the n plus 2 and x to the n. So copy the base and add the exponent. So we have n plus 2 plus n. And then y raised to, we multiply the exponents. We have a number raised to an exponent, raised to another exponent. Okay, so that's our numerator. And let me just copy x to the 2n plus 1, y to the 2n plus 1. Since I have same base over here, so for x, copy the same base x. So what do you do with the exponents? You subtract. Oopsies. N plus 2 plus n minus, don't forget the quantity. Okay? You're subtracting the entire 2n plus 1. And then I have y, 2n minus also the entire 2n plus 1. So what do we get? We have x to the 2n plus 2 minus 2n minus 1 y raised to 2n minus 2n minus 1. So we get oops. So we get x, right? The exponent will just be 1, and then for y, the exponent will be negative 1, which is the same as x times 1 over y, which is x over y. There you go. For this example, we want to find an equivalent expression for 3 to the m plus 3 to the m plus 3 to the m. First, let us recall this. if I have a number added to itself 3 times, what is that? So for example, I have 5 plus 5 plus 5. Let me just write it. 5 plus 5 plus 5. Of course, you know that that's 15. But where did you get 15? It's actually 3 times 5, right? So if you have star plus star plus star, what is the answer? It's equal to 3 star, right? Oh, there you go. What about, take note ha, there's a difference. If you have star or a number multiplied to itself 3 times, what is the answer? It's equal to star cube. So my point here is that repeated addition means multiplication, and repeated multiplication is the same as raising it to an exponent. Alright, so let's go back. What is now 3 to the m plus 3 to the m plus 3 to the m? Okay? Now, warning, you cannot do this. It's not equal. It's not the same as 3. What are you doing there? You're adding the bases and then you're copying the same exponent. There's no rule. There's no law like that. Okay, so remember that those are not equal. So in general, right, because if you have addition or subtraction inside your parentheses, you cannot distribute your exponent. Okay, so that's why they are not equal. You can only distribute it if the operations inside are multiplication and division. So let us recall, star plus star plus star is 3 star. So therefore, what is the answer? I hope that you are answering. Does anybody of you says it's 9 to the m? Okay, let's go back. Now this one, according to what we just recalled, this is the same as 3 times star. Our star in this case is 3 raised to m. Now my question is 3 times 3 raised to m equal to 9 raised to m? So what did you do there? You multiplied 3 and 3 and then you copied the exponent. Is that true? That is false. They are not equal. Why is that? Why why are you violating? Why you're violating the PEMDAS rule? Because what you just did there is you multiplied first, right? You multiplied 3 and 3, and then you raised it to an exponent m. So you're saying that multiplication came first before exponent, which is wrong. Okay? So now, let's now simplify 3 times 3 to the m. What is that equal to? You have the same base 3. So what do? Copy the same base 3 and then add the exponents. 1 plus. There you go.